Okay, let's look at the homework 4.5, 4.7, problem number 9. Right, so we have a right circular cylinder and is inscribed in a cone, right, with height h and a base radius is r, and find the largest possible volume of such a cylinder. All right, so let's do that. All right, first let's look at the side view of the cone. So it looks like a triangle. So I'm gonna give axes, x-axis and y-axis, so that we can use them as references. All right, so here is our x-axis. Right, and the y-axis is going to be probably around here. So here's the y-axis right in the middle. Right, and here's the origin. Right, and the cone, so the height is h, so I'm gonna put h probably right around there. So this is h, and the radius is r, so I'll just put somewhere right here, so r. Right, so the cone is going to, so h is going to be let's over here, so maybe a cone is going to look like this. So so here, so you have that. Oh, that doesn't look good. Let's do it again. There you go. All right, and you have on this side, maybe I'll draw a circle here so that make it look like a cone. Right, so like that, and so make it look like a cone like that. All right, so that's the cone. And we want the circular cylinder, so I'm going to call the radius of that cylinder x. So right here is x, right? Then draw a cylinder like this. Okay, so oops, that's not what I want to do. Here's the cylinder that's inside the cone. Right, and I'm gonna have to go straight up to here. Oop, that's not it. Yeah, I have to go straight up to, say, here. Right, then the circle is gonna look kind of like this. So this is the top side, and just connect those two guys together. All right, so that's the cylinder with radius x. All right, and the height is going to be determined depending on the x value we choose. All right, and so it's going to go all the way up to here. The equation of this cone up here, right, so this equation right here, equation there, so a y-intercept is h, and a slope is you go to the right units and go down h units. So this equation is y equals slope is negative h over r, and plus h. So this is the equation. All right, so what we can do is we can set up an equation for the volume of this circular cylinder. So this guy right here. All right, so this is the cylinder inside. All right, so let's try to find that. All right, so the volume V, and v of x is going to be equal to, right? Remember the volume of the circular cylinder is pi radius squared, so it's going to be pi radius squared times the height of the cylinder. height of the cylinder is going to be, you can just plug in x here, so height is determined by this equation. So it's going to be negative h over r x plus h. Right, if you want, you can just multiply out. So I'm gonna actually keep the h out, but I'm gonna just put x squared in there. So you have negative h over r x cubed plus h squared, right? And we want to maximize this volume, right? And on, right, x is a radius, so I guess it's going to go from 0 to r. That's the 0 is the smallest, and r is the largest. So let's maximize it over the closed interval from 0 to r. All right, so let's take the derivative. So v prime of x is equal to, right, so take the derivative. So pi is just a constant multiple, so leave it there. So derivative of that would be, right, so put 3 in front, so it's a negative 3h over r x squared plus, and put 2 in front, 2h x. Right, so x is in common, I'll pull it out. Right, so you will have negative 3h over r x plus 2h. Then we can set this equal to 0 to find critical numbers. Right, so critical numbers are, alright, first one is pretty easy. So x equals 0. Alright, another one would be here. We set this guy equal to 0. So that would be 2h times, so I have to multiply by reciprocal of that, r over 3h. So you can cancel that out. So it's actually 2r over 3. All right. So since we're trying to maximize over a closed interval, we can just check 3 places. So v of 0, and also another critical number, v of 2r over 3. And the other endpoint is v of r. Right, but these two are pretty easy. If you plug in x equals 0, right, so volume is going to be 0, of course. And if you plug in r here, so if you plug in r here, r and r cancel out, negative h plus h cancel out, so it's going to be 0 as well. Right, so as long as we get a positive value from here, we'll have a maximum there. All right, so just plug it in. So this is going to be pi, right, so x squared, so you have 2r over 3 squared, right? And if you plug in 2r over 3, will be r and cancel out. So you have, let's see, maybe I should put it in. So negative h over r times 2r over 3, right? And this, I'll put a square bracket here and a plus h here. Right, then simplify that, so you can cancel r here and r here. So you basically get from here, so you have a pi, and if you square that, the 4r squared over 3 squared is 9. And here you have negative 2/3 h plus h, so it's going to be 1/3 h, so it's h over 3. Right, so therefore you will get, let's see, 4 pi over 3 times 9 is 27 r squared h, right, which is a positive number. So we know that this is going to be the maximum right there. All right, that's that. Let's type it in. All right, so answer was 4 pi, so it's a Greek letter, 4 pi over 27 r squared times h. All right, so let's check the answer. All right, it came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.